Alright guys, welcome back to section 3.4 linear programming. In part 1, toward the end of the video, I went over and I showed you how we take this information and summarize it in a table. And now what we're going to do is we are going to write the constraints for the problem and also the function that we want to maximize. Remember that X represents the number of cases of wall calendar, and therefore that number should be no less than 0. Y, it's also the number of cases of pocket calendar, and that number should be no less than 0. So we know that those has to be bigger than or equal to 0. So make sure you understand what your X and Y stand for and write the appropriate inequality for those. Also, we know that our third constraint is we can have no more than 1,000 units. Remember that each box of wall calendar contains 24, so 24x would be the amount of calendars, the amount of wall calendars, and 40y on the other hand is the amount of pocket calendars. And if you add those together, they should be no more than 1,000. So what I did here is, once I did that, I also simplify them by dividing everything by 6 and then solve for y so that I can easily graph my inequality. The third constraint is the cost. Remember, you're restricted by the amount of money that you have, so you have $1,200. It does cost you $48 per box a wall calendar and $30 per box of pocket calendar. So you know that your costs should be no more than $1,200. And once again, I reduce and I solve for y, which gives me that. And so there are 4 constraints for 1, 2, 3, 4, but we simplify the last 2 into that. The next step is I'm going to graph the 4 constraints. Oh, by the way, before we graph the constraint, let's take a look at the function that we want to maximize, which is our profit function. We make $120 per box in profit and $90 per box of pocket calendar in profit. So our profit function is 120x plus 90y, and we want to maximize that. We want to make as much money as we can. So our objective function is that. Now we're going to go ahead and graph these constraints, and we're looking for the feasible region, which is the shaded regions. So here's what I did. I number off these units by 4. So 4, 8, 12, 16, 20, and 24, right? And then what I did was 4, 6, 8, 4, 8, 12, 16, 20, 24. Okay. So the next thing I do is I graph both of these. X greater than or equal to 0. X greater than or equal to 0 would be the vertical line at 0, right? And then it's shaded to the right. Y is greater than 0, which is the x-axis, and it is shaded above. I also graphed started off with at 25 as my y-intercept, and then slope is -3/5. So this dot should have been up there, all right, but it's okay. But just know that that dot right there is 0 and 25. And so I drew the line through my y-intercept with this slope, and then I'm going to shade below. On the other hand, the last line, the last inequality, I am constructing an inequality with an x-intercept, with a y-intercept at 40. So 40 is going to be up there. Slope is -8/5, so it's going to look something like that. And this line is also going to be shaded below. So all these shaded region is going to overlap in this area. All right, and I call that my feasible region. Now the next thing I have to do is I have to find all the vertices. Okay, and there are 4 vertices, and I label those A, B, C, and D. So A, B, C, and D. First, vertex A is actually very easy to find because vertex A is the y-intercept of this line, which is this equation. So that would be 0 and 25. Vertex B is the origin, 0, 0. Vertex C, it's the x-intercept of this function. So what I'll do is I will show you how to find the x-intercept using a graphing calculator, or you can do it by hand if you like. So I'm going to go ahead and plug both of these equations into my graphing calculator, which I did. And remember that the red line, the last equation is drawn using a red line. And what I'm going to do is I'm just going to change this so that you can actually see the shaded region. So both of these inequalities are shaded below. To get the shading to reveal on your graphing calculator, first what you do is you move that blinker over to the respective color, hit enter, and then I want you to toggle down like this until you see that line, and then just arrow left and right so that you can select the appropriate inequality of your choice. If you want the graph to shade below, then you don't want the upper triangle, you want the lower triangle like that. And then just hit enter a couple times, all right? Similar to the first inequality, because the graph is shaded below, toggle over to the respective color, enter, and then toggle down, right a few times, enter, enter, and now you have those shaded in the respective region. Now, say if you want to make your calculator go a little bit faster, what you can do is you can kind of reset your X resolution. So window, and then toggle all the way down until you see X res, and change that from a 1 to a 2. The bigger the number, the faster the processing speed. So I use a 2 because I want it to graph, in a timely manner. And once you've done that, then go ahead and hit zoom 0. Zoom 0. That's right, zoom 0. And it kind of gives you the 2 graph, right? And remember, we're interested in this region, in the shaded region, right? And so my next point is to find where this line crosses the x-axis, which is right here. That's the next vertex. So what we do is we find the x-intercept for the red line. So I would go second calculate, and I'm going to calculate the intersect. Or I'm sorry, I'm going to calculate the 0. The 0 is the point where the line crosses the x-axis, is also called a 0. The x-intercept is also called a 0 if you like to think of it that way. So I calculate the 0, and I'm going to make sure I'm picking the right equation. Notice that now it's on the right equation. Earlier it was on the blue equation, so I kind of have to toggle to the right equation because I want to find that x-intercept. So I go move that cursor as close to the x-axis as possible. So you go left bound, yes, and then right bound, move it just right below it, and then hit enter again. And then it's going to ask you, hey, guess a solution, but you can just ignore that part and just hit enter. And if you do, notice that it says, all right, the 0 has got 25 and 0, and that's the x-intercept. So 25, 0. Okay. So we found C. Now, we also need to find the point of intersection right here, which is D. Again, we need to go back to our graphing calculator, and we need to find the intersection of those 2 graphs, which is like that point. That's our point. That's the D point. Should do that. So, once again, second calculate. And this time, I'm going to be calculating the intersection of the 2 lines. So, hit option 5. It will say, what is your first curve? And so the blinker is now on the blue curve. So I hit, hey, blue curve is my first curve. What's your second curve? Well, second curve is the red curve. So I put my blinker on the red curve. And then it says, what do you think the solution is? And you can just hit enter. Ignore that part. Just hit enter. And it will say, oh, the solution is right there, which is at 15. I'm sorry, not the solution, the intersection. The intersection is at 15 and 16. Okay, so we got it. 15 and 16. So we have copied down the vertices of the feasible region, and now we have to evaluate the objective function at these ordered pairs. The function is going to be either maximized or minimized at one of these 4 ordered pairs. So we go P at point A, right? And you can annotate it however you want, but when I write, for example, P at A, I'm saying that x equals to 0 and y equals to 25. So 120 times 0 plus 90 times 25, that comes out to be 90 times 25, 2250. Okay. P of B, 120 times 0 plus 90 times 0, and clearly that's going to equal to 0. P of C, 120 times 25 plus 90 times 0. So 120 times 25, 3000. And then P of D, which is 120 times 15 plus 90 times 16. That is going to give us 3,240. All right. So now we answer the question. What is the maximum profit? What is the maximum profit right here? What is the maximum profit? The maximum profit is going to be 3,240. So max profit is 3,240. And perhaps we can also indicate the number of boxes that would produce that profit. Max profit is 3,240 when we order 15 boxes of wall calendar and 16 boxes of pocket calendar. All right. See you guys in the next lesson.